standard color management workflow using linear workflow with sRGB color profile. And this workflow we are also using for our entire course. In a Redshift camera tag, we can change color management workflow as well if you will use override and enabled. And again, default display mode is sRGB. But if you need to change your display mode for linear or rec or OCO, that's the place where you can find it. In render view, you can see sphere. For lighting, I am using dome light with colorful HDRI map. For this test, I am using standard Ares material. All Redshift materials using color and numerical parameters. Differences between them is color space. Color parts of material using sRGB color space, but numerical parameters using linear color space. In case that you would like to use two different color spaces works together, you have to use gamma correction. And I will show you now when we have to use gamma correction for our nodes and when we do not need to be worried about. Currently we are using Ares material without any additional nodes. In this case, all working just great and we do not need to be worried about color space. As first example, we will control diffuse color, which is color parameter, with color-based node. We will start with color constant, where we are using the same 50% of the gray as is diffuse color of our shader, connect color constant with diffuse color, and as you can see in our render view, we are getting the same result. It means everything working correctly because we are using color-based nodes to control color-based shader parameters. As next we have ramp node, again with 50% of gray. Let's do reconnect. And again we are getting correct result. The same with the noise. Colors are 50% of gray. Reconnect. And again we are getting correct result. And the most common color-oriented node is texture. So if you would like to use sRGB texture to drive your diffuse color, everything will work correctly because Redshift expecting in diffuse color to have sRGB textures. And please remember that if you are using color-based nodes to control color-based shader parameters, everything works correctly in terms of linear workflow. In this example, we will have a look on numerical-based shader parameters as roughness or diffuse weight, or any other numerical parameters which are controlled by values instead colors. And for our test, we will use reflection roughness with value 0.5. First, we will use numerical-based node constant with value 0.5 exactly as is our reflection roughness, connect them together, and as you can see, everything working very well because numerical-based nodes and numerical-based shader parameters using the same linear workflow. But what in case if I would like to use colors or textures to control numerical-based parameters? For this test, we will use color constant with 50% of gray, which should be equivalent of our 0.5 roughness. Connect them together into the reflection roughness, but as you can see, this time we are getting different result. And as you are expecting, it's happening because color-based nodes using different color space workflow than numerical-based shader parameters with linear workflow. So what we have to do to make it works? We will use color correct node. As next step, we will connect color constant with our color correct node and color correct node with reflection roughness. Select color correct node, and there we have gamma. And what we need to do is gamma correction. Default gamma value is 1, but we have to change it for 2.2. And as you can see, this gamma correction solved our problem, and now you can use color-based node to control numerical-based parameters. Let's do reconnect with digital constant again. And gamma corrected color constant. And we are getting the same result. In this example, we will use texture to control numerical base shader parameters. And as you already know, texture is color-based node, and color-based node needs gamma correction to correctly control numerical parameters. And in render view, you can see how looks our texture, which we would like to use. Connect your texture with the reflection roughness, select material, switch render view output from texture to RS material, and now we can see how looks reflection roughness connected to our texture. But even we are getting interesting results, we already know that we need gamma correction to make it works correctly. And again we will use color correct node, connect into his input texture and output reflection roughness. Now we need to change gamma to value 2.2, and as you can see in our render view, our texture is now correctly working with linear workflow. Texture node, to compare with other color-oriented nodes, has one extra feature which are helping with gamma correction. Let's connect our texture directly with the reflection roughness, select your texture, and as you can see we have section gamma override. If you will click enable, it will automatically make for us gamma correction. So in this case you do not need to use color correct node. And our texture is ready to control numerical base parameters. In this example, I will show you one more time what is necessary to do if you would like to use color constant, ramp and noise to control numerical base parameters as roughness or weight. Connect color constant into the color correct node. Be sure that gamma is 2.2 and connect color correct into the reflection roughness. As you can see in our render view, we are using correct setup. And the same workflow is for ramp node, just you have to connect your ramp node into color correct, and the same workflow for noise node as well. Now you know everything important about linear workflow, but if you are still interested, I can show you a few tricks. Some professional artists with years of experience trying to find easier way in their workflow, so sometimes you can see setup which using different nodes to get similar results as I showed you before. So I will show you how you can use multiply node instead color correct node for correcting our linear workflow. Multiply node has two inputs, so let's connect color constant into input 1 and output to reflection roughness. Default value in multiply node is 0 and we need to change it for 2.3. And now we are getting similar result as we had with the color correct gamma 2.2. And you can see in our render view that we are pretty close with this method as well. And the same workflow will work for ramp node and also for noise node. And as last example, I will show you how to use change range to get correct linear workflow results. Here we can see default change range values with new range max value 1. But if we would like to have correct setup, we have to use new range max 2.3 instead 1 as its default value. And 2.3 is the same value as we used in our multiply node. Let's connect our material into the output, and as you can see, again we are getting correct result. And now we can drive with color nodes, digital parameters of our material. Just be sure that you are using correct values. And again, the same workflow is working for ramp node and for noise node as well. In this chapter, I will show you how works RS material. In material section, I have ready two materials, and if you will select one of them, you will see his parameters inside the shader graph. We can directly drag and drop our material or model in object section, and as you can see, material has been applied. Select second material, we have updated shader graph again. And we can also drag and drop material on our model directly in 3D viewport. And in render view, you can see how looks our material now. In shader graph, we can control parameters of our material. As you can see, if you are using Node to drive your parameters, you have not access to these parameters inside shader section anymore. In the next chapters, I will show you all important details about all RS materials sections, include multi-SSS, coating, and overall section as well. Now I will show you how to create new material. Go to Material section, Create, Redshift, Materials, Material. And in Material section, we have new RS material. We can use our new material to replace old one. As you can see, new material has been applied on our Dragon, and we can control now RS material parameters. I switched from layout 14 to layout 15. Let's to create new material, Redshift, Materials, Materials, Material, which is standard RS material. Apply our new material on our model. In layout 15 we have more space for shader graph. And now we will have look on material presets. Material presets are very good start point and very often speeding up our workflow. You can use them to learn how works different materials. We will start with the glass. And as you can see, glass is not using diffuse color, but it's using reflection and refraction as well. As next material, we have tinted glass. And again, as we can see, here we have subsurface material. So it's another good start point in how it works subsurface. Next preset is water. And water is using dispersion. Next preset, we have plastic. And plastic is using diffuse color, but it's not using refraction. Another preset is aluminium, and metals are not using diffuse color, but they need specify Fresnel type. And next preset is copper. And you get an idea why to use material presets and learn how they work. In my case, I am using material presets to speed up my workflow. In this chapter, we will have look on diffuse part of RS material. As first we have color parameter, which defines color of the surface. Black diffuse color means no diffuse lighting. We can use color swatches exactly the same way as I showed in other chapters. Very often into the diffuse color is connected texture, which contains much more details, but if you would like to use texture, you have to have correct UV coordinates. We can use texture node and load our texture, or just copy and paste from different shader. We can delete empty texture node to keep it organized, and now we can connect our texture into the RS material, base properties diffuse section, diffuse color. Common name for diffuse texture is albedo, and details about texture node we will have in separated chapter. In render view, we can see how looks our model with diffuse or albedo texture. If you will click on material tag, you will get access to projection section where we can change type of the projection. But in this case, our model has UV coordinates, so we will use UV mapping. As next parameter, we have diffuse weight, which controls diffuse contribution. Value 0 means no diffuse lighting, and it's common for metal, liquids, or refractive materials. And here are examples of different weight contribution. As next we have diffuse roughness. This controls roughness of diffuse lighting. Increasing of diffuse roughness is good for materials as dirt, dust or other rough surface materials. I will show you few examples how works diffuse roughness from value 0 to value 1. As next we have backlighting. Backlighting we can use as cheap solution for very thin materials such as paper or leaves. For backlighting results, you have to increase your backlighting weight values. 0 values means no backlighting contribution. Also, we have control of backlighting color. You can increase brightness or saturation of backlighting color. And as you can see, weight control intensity of our backlighting color as well. Our Dragon is not the best example for backlighting feature, and in this case it's better to use subsurface scattering. But let's to have a look on example where backlighting feature is meant to use. And as you can see, for leaves, backlighting weight around 0.1, producing very nice results.